How Coatings Protect Metal by Bailey Compton, Jared Kazin, and Daniel Fraser. Today's modern world heavily relies on its systems of global trade. These global trade systems heavily rely on the maritime industry as its backbone. The maritime industry's cargo ships carry everything from livestock to oil to cars to grains to people to and from ports all over the world. Now, these cargo ships are made out of steel primarily. Steel is a great building material for these ships because it has a low tensile strength, high density, and it's very efficient. Additionally, it's also very cheap. The tensile strength for steel is somewhere between 400 and 500 megapascals. It has a density of about 8,000 kilograms per meter cubed, and it has a strength to weight ratio of 50,000 joules per kilogram. Now, unfortunately, when steel interacts with moist environments similar to those that a cargo ship would experience at sea, it will begin to rust. Uh, Steel has a anionic reaction that strips electrons from it at peaks and inclusions on a microscopic level. When these electrons mix with water molecules, they begin to rust. And this rust weakens the hull, which is bad news when you're floating thousands of tons of material. So the question becomes, how can we prevent water from rusting the steel that our cargo ships are made out of? One way that people have figured out how to do this is by coating the steel in order to make a barrier between the water and the steel itself. Most of these coatings come in the form of epoxy paints. Europe uses about 51,000 tons of these epoxy paints to coat their ships a year. The way that these epoxy paints work is that they fill micro imperfections and cracks that are in the steel, and this prevents the electrons from escaping those weak spots, mixing with the water, and causing rust. Some of the benefits of these coatings is that they are flexible, so they can move with the ship without peeling. They have a quick cure time to decrease maintenance and manufacturing costs, and they're weather resistant and sunproof. When applying these epoxy coatings, the metal first needs to be stripped of any rust or imperfections. After the rust and dirt has been stripped off the metal, a base layer is applied first in order to boost adhesion and add a secondary protective layer to the metal, after which the epoxy coating is then finally applied.
Okay, so some of the downfalls that this coating has is that over long periods of time, when it's exposed to the sun, it has long-term UV exposure. This can degrade the coating that we use, and that will eventually lead to corrosion getting on the metals that are used, normally steel. Um, but corrosion will eventually get on it after the coating is degraded because of how much exposure it gets to the sun when it's out sailing all the time. One thing that we can do to help this out is regular inspections. These inspections will be used each time that the boat is docked. You look at the coating, make sure it's all good, and if it's not, then you need to say something. That coating can then get replaced. You can reapply coating, everything like that. It's not that big of a deal. The zinc phosphate inhibitors, though, does block the corrosion reactions. This is huge because um, it blocks out any kind of corrosion to come onto the metal. It makes it less likely, and it helps out with it makes it long term, like dramatically. This may be a little bit more expensive on the hand because it's zinc, but in the long run, it would be very, very uh, useful. Our findings that we had found on the boat trip, our group specifically did not get to go on the boat trip because it was canceled, but based upon what we were finding from other people's pictures, this shipwreck was one of the biggest things that caught our attention, and then the coordinates are right there on the slide. This location is the outcome of what would happen without these coatings. The ship would corrode, eventually causing it to get shipwrecked. The hull could be damaged, causing water to come on. Everything could go wrong. This goes perfectly with each and every single one of our majors. Most of us are marine engineering. Um, so this is what we are trying to prevent in our industry. This specific thing right here. Corrosion is one of the biggest things that we have to deal with, especially with the salt water. It controls everything. Corrosion is the biggest thing for us to prevent when it comes to ships, any kind of metal, oil rigs, anything like that. So this was the biggest example, real life example of our thesis on how the coating can really help prevent corrosion and help with these shipwrecks. I mean, these shipwrecks would not be here anymore. Then finally, our thesis. We decided to choose this because, like I said, each and every single one of us are marine engineers. It's what we would like to go to, any kind of naval architecture, marine engineering, that goes directly into it. The chemistry of this we have to know, especially with dealing with salt water. It is a vital importance to everything when it comes to designing ships, building ships, anything that goes into the ocean water. Finally, these are our sources that we used. Um, these are our two sources we got all of our information from based upon the polyurethane and the epoxy coatings that we were using throughout the whole presentation. Thank you.